Bismillahirrahmanirrahim. Okay guys, sorry for the delay because I should share with you all the tasks whereby we shall use what's so called the sweep function. Sweep function. So you can find sweep parameter sweep here and put somewhere inside your circuit. Okay, previously we have discussed on how to execute or how to access the machine, and we use this DC machine. So you can select from element, power, the motor drive module, you select DC machine. So you come up with this one. So meaning whereby this is DC machine, so you have to select DC source, and we have to measure their voltage, we have to measure the current, we have to measure the current also in the field. So you need two voltage current probe, one voltage probe. Okay, you connect all of them together. Connect the current meter first. Connect the current meter from field circuit towards parallel with your armature circuit. Then connect your voltmeter. Connect your voltmeter. And please label properly. So you can double click. The name you can put here, armature current. Armature current. So later inside your simulation, you can indicate directly what the curve represent from the circuit. So this is your field current. Click on the display, so it will display accordingly. So this is your voltage V in. And your V source we set at 120 volt, is it? 120 volts. So 120 volt coming. And this is your electrical part. Motor will convert from electrical to mechanical. So for mechanical output, you should put another sensor, which is, you can search for torque control. See here, torque sensor. So you put torque sensor here. Then we need another speed sensor. Speed sensor. So here is your speed sensor. Then you connect to your, previously to your load. And you can search for load or come out with here. We have mechanical load, constant torque at that time. Is it? Mechanical load, constant torque. Mechanical load, constant torque. But at this time, you take out this load, replace it with simple resistor. And click resistor, put it here, and you ground that resistor, and we shall put another voltmeter across our resistor, and also ammeter in line or in series with our circuit here. So this should be your V out or V load. V load. Meanwhile, this is your I out or I load. So label accordingly such that you can recognize what the curve is representing. Okay, never mind. Okay, means that we have complete the circuit. So before you run, search for where is it, the simulation control? Yeah, simulation control. Put it here. So as we run previously on your circuit which run on linear load RLC, it can run, or it can stabilize, or it can reach a constant state after a few milliseconds. But for machine, so be reminded that machine is a mechanical load which involves inertia. So put at least 10 seconds, let's say. So after that, you can see how it responds, where at what time it stabilizes. So you can reduce accordingly. You can reduce maybe down to 5, 3 seconds or 4 seconds like that. Okay, first of all, use 10 seconds. Okay, before you run, you set your resistor value highest value possible, because we try to imitate the so-called open circuit. Open circuit to see how much actually it measures at this point, and how much actually it measures at the incoming or at the load terminal. Okay, try to run, see what is the values there. So we have not put yet the voltage probe here for torque and speed. And so this is your torque. This is your speed. Okay, run the simulation. Still have RLC branch is floating. Resistance is 10,000 ohm. Okay, actually we forgot to include the mechanical to electrical converter. So the interface, so mechanical to electrical interface, because we cannot run electrical circuit on mechanical circuit. We have to use the interface, and only we can run. So click run. So it should be running in background, and try to see what are because the output of motor should be in terms of their speed. And so you can see here the speed, and also we can add screen to see the torque, how the torque respond. Actually we have a constant torque, so the torque will increase and will be standardized or constant at certain value. So we try to see the armature current, how much it consumes to run the motor. You can see here. So you can click this probe to see what are the response at certain times. So you refer to X1 here. X1. So this is the value when the motor start to break, starting current, and it's going to went down to operating current, which is the current about 0.18 ampere only. Starting current, it can reach up to 200 ampere. See, once the speed is standard constant, increase and constant, so at that time current reading or current consumption also will reduce. So this is the one value simulation result of our setting. So we set at highest possible, let's say 1000 ohm, to represent the output at this value. Let's say we want to analyze the machine when it operates from minimum load up to maximum load. 1000 ohm represent minimum load. Means the higher resistance, lowest current consumption. So this to represent minimum load. So how to set such that we can operate. We can see how actually the performance when we increase the load gradually. So let's say we try to, so we put here the resistance value as a reference. So let's say we put a load. We don't put value here, we put a reference name. Then when you use parameter sweep, so what you have to put here, you can have to call back the name that you have put inside your resistance just now. So let's say we assume that 1000 ohm is our minimum value, and 1000 ohm is minimum value of current, means higher resistance. So we can start, let's say, with 100 ohm. It ends in 1000 ohm. So increment in terms of 100 ohm. So 1000 divided by 100. So we have 10 data there, and 10 data. Okay, you can run. You can see how the output will be. Okay, after you run, it comes out with like this. So just now we look at their speed, torque, and armature current. So you select here again the speed. All of the speed here you have to select. All the speed here. You have 10 points. So add the screen and generate your speed. So we have here. So where does it go? Sorry. Okay, after you have run, so when you select the curve here, you can add all together to display on your screen. So if we compare each of your data or parameter that you want to see your response, we compare here. Let's say in terms of speed 1 up to speed 6 setting, 100 ohm up to 1000 ohm, let's say. So we can see that if we probe here, the reading at steady state, let's say around here, the speed is almost the same. X1 almost the same, just increase a little bit. In terms of your current, armature current, so armature current 1.4, so 0.47, 0.28, so a bit difference or increasing based on your setting. You cannot see in actual or in gross, or so-called, can visualize unless you have to measure. But in terms of torque, you can see here, you can generate the data and you can jot down the data itself. Yeah, we have here 1.3 for 0.43, 0.2619, reading of all the torque. Means that if you want to perform analysis in terms of the performance, let's say the output speed, output torque, when we shift the value of our output resistor, so we can run simultaneously and all together. Then we can jot down the data here and put in our Excel and generate the torque. So this is the time response of our machine. We get the data here to analyze in terms of their performance. Okay, that's all for sweep function. Hope you can use this method to analyze your machine. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.